Hi, I'm Agnes Ona, and together with Kim Jersey Hizo and Herdel de la Cruz, we will be talking about neural networks. So, what is a neural network? A neural network is a method in artificial intelligence that teaches computers to process data in a way that is inspired by the human brain. It is a type of machine learning process called deep learning that uses interconnected nodes or neurons in a layered structure that resembles the human brain. It creates an adaptive system that computers use to learn from their mistakes and improve continuously. Thus, artificial neural networks attempt to solve complicated problems like summarizing documents or recognizing faces with greater accuracy. So based on this definition, we will never understand neural networks without first understanding artificial intelligence, machine learning, and deep learning. So before having a deep dive to neural networks, let us first have a backtrack on this tree. Artificial intelligence is the field of computer science that researches methods of giving machines the ability to perform tasks that require human intelligence. Machine learning is an artificial intelligence technique that gives computers access to very large datasets and teaches them to learn from this data. Machine learning software finds patterns in existing data and applies those patterns to new data to make intelligent decisions. Deep learning is a subset of machine learning that uses deep learning networks or neural networks to process data. So now that we did a backtrack on artificial intelligence, machine learning, and deep learning, let us find out the difference and at the same time the connection between machine learning and deep learning. Traditional machine learning methods require human input for the machine learning software to work sufficiently well. A data scientist manually determines the set of relevant features that the software must analyze. This limits the software's ability, which makes it tedious to create and manage. On the other hand, in deep learning, the data scientist gives only raw data to the software. The deep learning network or neural network derives the features by itself and learns more independently. It can analyze unstructured datasets like text documents, identify which data attributes to prioritize, and solve more complex problems. So why are neural networks important? Neural networks can help computers make intelligent decisions with limited human assistance. This is because they can learn and model the relationships between input and output data that are nonlinear and complex. Neural networks can make generalizations and inferences. It can comprehend unstructured data and make general observations without explicit training. For instance, they can recognize that two different input sentences have similar meaning. Can you tell me how to make the payment? How do I transfer money? A neural network would know that both sentences mean the same thing. Or it would be able to broadly recognize that Rizal Street is a place, but Dr. Jose Rizal is a person's name. Neural networks have several use cases across many industries, such as the following: medical diagnosis by medical image classification, targeted marketing by social network filtering and behavioral data analysis, financial predictions by processing historical data of financial instruments, electrical load and energy demand forecasting, process and quality control, and chemical compound identification. There are also four important applications of neural networks, which are computer vision, speech recognition, natural language processing or NLP, and recommendation engines. So now that we know what are neural networks, its importance, and had a backtrack on artificial intelligence, machine learning, and deep learning, let us now understand how neural networks work via artificial neurons. The human brain is the inspiration behind neural network architecture. Human brain cells, called neurons, form a complex, highly interconnected network and send electrical signals to each other to help humans process information. Similarly, an artificial neural network is made of artificial neurons that work together to solve a problem. Artificial neurons are software modules, called nodes, and artificial neural networks are software programs or algorithms that at their core use computing systems to solve mathematical calculations. A basic neural network has interconnected artificial neurons in three layers: the input layer, hidden layer, and the output layer. From the input layer, the information from the outside world enters the artificial neural network. Input nodes process the data, analyze or categorize it, and pass it on to the next layer. The hidden layers take their input from the input layer or other hidden layers. Artificial neural networks can have a large number of hidden layers. Each hidden layer analyzes the output from the previous layer, processes it further, and passes it on to the next layer. The output layer gives the final result of all the data processing by the artificial neural network. It can have single or multiple nodes. For instance, if we have a binary or yes or no classification problem, the output layer will have one output node which will give the result as 1 or 0. However, if we have a multi-class classification problem, the output layer might consist of more than one output node. So these three, the input, the hidden, and the output layers, are what consist a basic artificial neural network. On the other hand, deep neural networks or deep learning networks have several hidden layers with millions of artificial neurons linked together. A number called weight represents the connections between one node and another. The weight is a positive number if one node excites another, or negative if one node suppresses the other. Nodes with higher weight values have more influence on the other nodes. Theoretically, deep neural networks can map any input type to any output type. However, they also need much more training as compared to other machine learning methods. They need millions of examples of training data rather than perhaps the hundreds or thousands that a simpler network might need. So artificial neural networks can be categorized by how the data flows from the input node to the output node. It can be a feed-forward of information or a backpropagation of errors. So these two types of neural networks will be explained to us by Kim Jersey Hizo and Herdel de la Cruz.
I'm Kim Jersey Pihiso from second year BSIT, and I will be tackling feed-forward neural networks, or a simple neural networks where connections do not form cycles. Feed-forward artificial neural networks. A feed-forward neural network, or ANN, is a type of neural network in which the information flows in only one direction, from the input layer through one or more hidden layers to the output layer without any feedback or loops. And it is called feed forward because only the data moves forward through the network and never loops back on itself. Or second one is in a feed forward ANN, the input layer receives input data and each neural in the input layer is connected to the neurons in the next layer, the hidden layer. The hidden layer can contain one or more layers and each neuron in the hidden layer is connected to the neurons in the output layer. The output layer produces the input for a given input. During training, the weights of the connections between the neurons are adjusted using back propagation to maximize the error to minimize the error pre- between the predicted output and the actual output. Once the network trained, it it can be used to make predictions on the new data. Use, use cases of feed forward ANN. Feed forward artificial neural networks or ANNs are widely used in machine learning and artificial intelligence. They can be applied to any problems including number 1, pattern recognition. And FFNS are effectively recognizing patterns in data such as images of sound. They can be used for image recognition, speech recognition, or even music genre classification. Number 2, prediction. FFNNS can be used to predict future values based on the past observation. This can be applied to financial forecasting, weather prediction, or predicting customer behavior. Number 3, control. Can be used for controlling procedures such as optimizing production process of controlling traffic signals. In number 4, robotics. Can be used in robotics to control the movement and navigation or to recognize objects and environments. Number 5, neural language processing or NLP can be used to tasks such as sentiment analysis, text classification, and language transmission. Number 6, time series analysis can be used to analyze the time series data such as financial time series or sensor data from Internet or Things or IoT devices. Anomaly detection. This can be used to detect anomalies in data, such as fraud detection in financial transaction of or industry detection in computer networks.
Hi, it's me, Herdel de la Cruz, a BSIT student, and for today, we're going to talk about backpropagation artificial neural networks, a technique used to train neural networks by adjusting weights based on error. Backpropagation artificial neural network is a supervised learning algorithm used to train a feed-forward neural network. It is the most popular and widely used algorithm for training artificial neural networks. Backpropagation is a learning algorithm that adjusts the weights and biases of the neural network based on the error between the predicted output and the actual output. The algorithm works by propagating the error backwards through the network, from the output layer to the input layer, and adjusts the weights and biases of each neural along the way. The backpropagation algorithm consists of two phases. The first is the forward propagation and the second is the backward propagation. During the forward propagation, the input is fed in the neural network and the network calculates the output. During backward propagation, the error between the predicted output and the actual output is calculated, and the weights and biases of each neuron are adjusted to reduce the error. The backpropagation algorithm uses the gradient descent optimization method to update the weights and biases of the network. The gradient descent method calculates the gradient of the error function with respect to the weights and biases, and then updates the weights and biases in the direction of the negative gradient, which reduces the error. Backpropagation (ANN) can be used for a variety of applications, including image classification, speech recognition, natural language processing, and time series prediction. It is a powerful and effective method for training feed-forward neural network and has been used successfully in many in real-world application. Use cases of backpropagation ANN. Backpropagation artificial neural network have been used in a variety of applications. Here are some common use cases of backpropagation ANNs. Number one, image recognition. Backpropagation ANNs have been used for image recognition tasks such as recognizing handwritten digits, classifying images, and detecting objects in images. Speech recognition. Backpropagation ANNs have been used for speech recognition tasks such as transcribing speech to text and identifying spoken words. Natural language processing or NLP. Backpropagation ANNs have been used for NLP tasks such as sentiment analysis, machine translation, and text classification. Time series analysis. Backpropagation ANNs have been used for time series analysis tasks such as stock price prediction, weather forecasting, and predicting trends in financial data. Robotics. Propagation ANNs have been used in robotics to control movement and navigation or to recognize objects and environments. And the last one is the anomaly detection. Backpropagation ANNs have been used to detect anomalies in data, such as fraud detection in financial transactions or intrusion detection in computer networks. Okay, so since we already know how feed-forward and backpropagation works, we're going to differentiate those two. To summarize, the main difference between feed-forward ANNs and backpropagation ANNs is that backpropagation ANNs use feedback loop to adjust the weights and biases on the network during the training process. This feedback loop allows propagation ANNs to learn from their mistakes and improve their performance over time, while feed-forward ANNs, on the other hand, are simpler and have no feedback loop, making them less complex and easier to implement. In practice, both types of ANNs have their own strengths and weaknesses, and the choice of which to use depends on the specific problem and available data. Feed-forward ANNs are often used to simple classification tasks, while backpropagation ANNs are used for more complex tasks. Okay, so since we're already set, thank you for watching. And if you have questions and want to learn more about the topics discussed in this presentation, you can also check the links of our references that you can see in this presentation as well. So once again, thank you and have a great day. Bye.